Tanya. So we are, we've been a maths active school since last year, earlier last year. To be honest, it actually came about from the students. So I'll talk about a little bit about that. So we're on the other side of the West Gate. Yep, there are schools out there. And we've got, we're on Point Cook Road, we've got over 780 kids at our school now. In 2012, we introduced a mathematics extension program. So that was basically for the top 10% of kids. We sort of saw that there was a real gap in the classrooms. We tested the kids on, we used some on-demand testing in the first year, but that didn't work out. Then we ripped off old A&C tests, like questions from that. But we made them not multiple choice, we made them just open, and we used that information to kids. So we have about 120 kids in the year level, so it was about 12 kids. For 4 years we did this program, and myself and the other maths leader, his name's Mark Gleeson, he'll also be presenting at the math conferences. And we once a week we'd take them out and we'd do problem solving just with these 12 kids, so from grade 3 to grade 6. And it was working really well, and we thought, and the kids were loving it, and we entered them in competitions and they won them, and we some of them went on to get scholarships, and it was all happening. What we sort of worked out was that the kids who was the 13th kid and the 14th kid who didn't get in the program, they weren't getting the good teaching and they were missing out. And initially when we started doing it, there was a big range between like the really top kids and the rest of the kids. So it sort of worked for a few years, but then this year we sort of realised that it's not working as well, and that it was becoming quite exclusive, and people were walking around. And because we love acronyms, I'm in MEP, I'm a MEP kid, and other kids are like, why aren't I in MEP? Why can't I be in MEP? And so we've got rid of it. This year we've changed it to, everyone in from grade 1 to grade 6. We do a different program in prep, but everyone is now part of the program. So initially what we did was we had the George Polyer approach. So I don't know if anyone's read this book. I've got we can provide you with. It's actually available online now as a PDF. It's not a great read because it was written like in the 40s. But it's basically, he was the guru of problem solving, George Polyer, and he came up with this whole problem solving process. So when you see a problem, you understand the problem, devise a plan, carry out the plan, and look back. So we sort of took that idea and we sort of changed it to this: understand the problem, make a conjecture. We're all into estimating and stuff like that, experimenting and then finding a solution. And again, it was sort of working quite well, but then we sort of thought, after a while we thought, you know what, we need to change it. So this year we relaunched the program. It includes everyone in the year level. There's one session per week, and sometimes we split the kids in sort of more ability groups, but they're very flexible, and it depends on the problem, and it depends on what area of the curriculum we're studying. So different kids, and kids move between the groups, and different teachers take different groups. So you're not always in Miss Lowry's group and Miss Lowry's the top group. I will move between all of the groups. So everyone's getting the good teaching, not just one group of kids. And we also work with myself and the other maths leader. We work with the teachers, so it's not our little exclusive group. It's training up the teachers. So being part of a maths active school is like training the staff as well. So if something happens to me tomorrow, the program can continue. It's not just my program, which is really what it was in the past. We use the Peter Sullivan.
Sorry, can I ask you a question?
Yeah, no problem.
You've don't do it with the whole group.
Yes.
And then you've sort of split them into ability groups,
yes.
Medium, and whatever. And you say you're taking the top group. Do you move, or does the student move?
So now I don't take the top group. So if there is 4 groups, there's 4 classroom teachers, and then I would be the 5th teacher. So I work with that teacher. So 1 week the kids stay and I would move. I move.
What I wanted to know.
Yes, but the kids, we also always reassess. Yes, we did it yesterday, and 2 of the students in one of the groups, we sort of said, they're not in the right group now. Next week we're going to put them back to the lower group, and then one girl who was in the lower group, we're going to move her up because she was absolutely flying. So we move the groups around, and I won't always be in charge of the top group, because if anything, you know, the teacher with more experience might need to be with the lower kids because they have the biggest gaps. So we move it always around.
I'll jump in there too. Even in our older levels of grade 5s, we do the same. So we would have 5 teachers rolling around in the teacher mould. Or, for example, if we wanted to watch Mark, who's our maths leader, on how he takes an approach to a problem, then we go and observe him, and then the kids sort of go, oh, I'm in this group this day. And they get this feeling that they're achieving because they've got different teachers each time. And even your low ones, they start to go, oh, we've got this one this week. You know, it's a really good feeling within the classrooms.
Because the students want to be working with the mathematics leader because they go, oh yes, I'm working with the math. So we've got a real buzz at our school about being a good mathematician. So because we're fortunate enough that mathematics leaders are out of the classroom, we don't have our own grade. So it's sort of almost, you get the special teacher, you know, it's exciting getting the extra teacher as well. So we use the Peter Sullivan approach, and we're actually involved in a project with Peter Sullivan out at Monash on multiplication at the moment. And if you haven't heard Peter Sullivan speak his idea is basically you put up the problem and then you go sit down. You don't say anything. And I think that's a real a sort of a challenge for our teachers to sort of put the problem up and not say anything. Even reading it to the class, because as you read it out loud with your own, the way that you read, you focus on the key phrases within the problem and you're sort of giving the game away. So, but there's obviously, Peter Sullivan would say there's a lot that goes behind that. So we've talked about the problem with the teachers and talked about what prompts will we use if things go wrong, what equipment will we have in the room, what other resources will we need, what other prompts might we use if children... Sorry. If we run into issues, and what misconceptions might come out. So there's a lot that goes behind that. It's not just about picking a problem off the internet and chucking it up and not doing any pre-thought. There's a lot of thought has gone into why we've picked that problem and stuff like that. Okay. And we do a lot of stuff on growth mindset. So, good mathematicians. So hands up in this room who thinks they're a good mathematician. Okay, so I would have hoped all hands were up. We do this stuff from the start. So we do this stuff from the parents. The first day that they get to our school, I speak to the parents about good mathematicians, and I said, we are all good mathematicians in this room, because I said we were having a meeting at 9 o'clock and you are all here. You've all managed to arrive on time. You've not, well, I don't know, you've followed the speed limit. You've been able to estimate what time you needed to get up so you could have a shower, so you could get the breakfast, so you get the lunches in the bag, get to school, get to the meeting. We've all been able to do that. So we're all good mathematicians, yet people do not see estimating as a mathematical skill, and yet it's one of the big ideas in mathematics, yet we don't associate that with mathematics. We associate times tables, especially in primary school.
Oh, yeah.
Times tables is just like, when do I teach my son the times tables? And we're like, no. And we do parent information nights about times tables and how there's a chart which is 28, like there's only 28 ones that you actually need to learn, and that just blows people's minds as opposed to the 144 we all had to learn. So we talk about good mathematicians, and we want to show a video of the kids talking about it. If you've got any questions, ask.
A person who organises their thinking clearly and access to different strategies to get the answer.
Someone who explains their answer and backs up their answer with different strategies.
Takes their answers. So what makes a good mathematician is how you know the question and then you find a strategy to find out the answer. Listening, understanding the problem, and having fun.
Good mathematicians will prove their answers.
In order to be a good mathematician, you need to understand that equation is quickly and not get confused by that. Yet, there's its own confusion, and it's a great for learning math. Plus, when you get confused, you always find an answer somewhere. And when it happens, it gives you a nice feeling of reward, making you want to learn more, making you a good mathematician.
I'm a good mathematician because I'm a good listener. Two, because I always double check. I'm a good mathematician because I never give up. At home, I practice maths.
When I'm doing problem solving, I always share my ideas and use the help of my strategy for accuracy.
I'm a good mathematician because I read the questions and I think hard. I'm a good mathematician when I learn different strategies and I find different solutions and I have good memory and great knowledge of what I do. Because I try hard.
Sometimes working in a group can help you come up with different strategies for other ways of working that out. And then you can apply that other strategy that your friend might have given you to a different question, and then it becomes easier, and you have loads more strategies to use on different questions.
When I am struggling, I don't close my book and give up. I keep on going and ask someone else.
I keep on persisting until I've reached the edge, and then I would ask a friend or teacher for help.
What I want to do, you can just ask someone to help.
I try to start a game or ask my friends to help me out.
I share my strategies with other people, and I always think wisely what would be the answer, and if I'm not sure, I always ask another. I try solving it all different ways.
I compare the question to another question that I know, and I get the answer like that.
Yeah, you can ask somebody to help you.
I use another strategy.
You go deeply into your brain and think. Nojo used to give up that school because he failed, but when he failed, he gets smarter and smarter every day.
Okay, so that's actually what he said. You go deeply into your brain and think. Great, so that was grade 1 to grade 5 students. It just happened to be, grade prep to grade 5, to grade 6 was somewhere on the day. Yeah, so it's this, that's the kids saying that stuff. So we have done a lot of stuff on Joe Bowler, and in that, I don't know if anyone knows about this series, it's called Class Dojo. You don't have to sign up for, I'm not promoting the Class Dojo app or anything, but their resources are free, it's on their website. So you can just sign up, and basically these two characters, this is Mojo, that's what the last boy was talking about. He said Nojo, but we'll let him off. That's Mojo and Katie, and at the first episode, Mojo, he's going to chuck it in, he doesn't like school. And Katie goes, no, you know, you can keep learning, mistakes grow your brain. And there's all this, we've used it Prep to 2, and there's all this, and it's like, it sort of looks like Octonauts, which is a very popular kid show, and the kids just sit there and they lap this stuff up, they love it, and they walk around and they make, like they believe it, and they say it to each other and stuff like that. And in the upper grades, we use this Joe Bowler stuff. I'll let Tanya talk about that.
So, we use this video at the beginning and on the mindset at the beginning of the year for our first maths lesson. And we showed it to the students, and they were thinking, what are they doing showing this for us? It was after the question, who's a good mathematician? And we showed it, and you could almost see the relief on their faces for some of them who didn't think they were good mathematicians, and then at the end of it, and even like at the beginning, so who's a good mathematician? Majority of the kids will put their hands up now. Even my ones who we would call the enabling group, a couple of sessions behind the others, they're like, oh no, I can do this. I know that I keep trying at it, and I don't have to be as fast as the person who can do their test in a minute. I can still get all the answers right, I just have to get a bit longer. So this set them up really well, and they go back to me and go, oh well actually if I get that wrong, I'm just going to get a bigger brain. And then they just keep taking that next step forward.
So like I was saying, we sort of thought the problem solving process, and we haven't talked before, but it was interesting that everything was sort of in a cycle, because that's where we've sort of come from. So originally we had that sort of the George Polio one, which was sort of just a process, and you start at the start and you finish. And we're thinking, well, maths is not like that, and real life is not like that. So if kids get it, well, because you've got a huge range in your classroom, like they're saying up to 5 years or something now or more in your classroom, even because we've got straight grades. And so kids were going, well, I get this problem. So then they were bored by going through all the steps. So I wasn't sort of embracing this idea that mathematics is engaging and practical in real life. So we actually visited St Mary's Williamstown, and they do another competition from the Australian Mathematics Trust, and that's very structured, and their workbooks were immaculate, and we were like, they're doing something right, and ours look like, a dog's breakfast, and we're not doing something right. So we sort of learnt from them. So we got the idea that maybe we needed to change it. So this is what we had, and then Tanya came up with this idea, and we called it the problem solving web. So we haven't put a copyright on it yet, so maybe get in there and do that. But now it's this idea that you can come in, when you see a problem, you come in with what you know. So depending on where you go, you might know something about it, so you start there, but you might already know the answer to that problem. So that problem that Jim put up before, you might have straight away known the answer. For you, it wasn't a problem. So you've got to be, there's a mistake there. I've just noticed that. This one's meant to say record your thinking. Yeah.
It's on the other one.
It's on the next one.
So it was good within the classroom situation. So this is the one that's on my wall. So we've got the Joe Bowler quotes up there to remind the kids. But so like I might have a student who comes in, they don't know, so they're recording what they know, whereas another student who's doing the same problem comes and go, oh, well, I know that, so they've already started recording their thinking, and they can go to the next one because they've explained their solution, and they could even explain their solution to their buddy to help them out. So it's sort of going on, but it does go round, but it's sort of, they can come in sort of here or over here,
and if they get to, if you don't know anything, you've got no idea about that problem, you've got a question, I've got no idea about it, what do I do? And then who do you ask? And you can hear in the video they were saying ask a buddy, very few people were saying ask a teacher. It's asking a teacher. Sometimes I sit there and think, oh, I'm doing myself out of a job here because the kids are so engaged, and I'm sort of walking around and I go, oh no, go over, sorry, we're not finished yet. And I'm like, oh, I'll go to another group. So it's sort of like when it's working, they're all helping each other, and your role changes as sort of more of a guide, not like at the top, like what I'm doing now. So you can see the Joe Bowler stuff better here. Everyone can do maths, believe me, struggle, mistakes are important, speed is not important. So you've got to think about as well, what are you sending home? Are you sending home fast facts? Or what are you valuing? So you've sort of got to rethink what you want to get out of your lesson. So if you want to have a focus on talking about your strategies, well then maybe that your focus is not about writing everything down. So they came up, we got this idea from St Mary's. So again, what you were saying, visit other schools, but because they're in because they're in a competition, it's very structured about their workbooks. And Tanya's got some examples of the bad ones.
Before and after, not the we'll go before and after. So what we did is based on the Peter Sullivan model, where he got us when we went on this challenging task project with him and Monash. They said that the students need to record all they know about the problem, then they have a section for all their rough working out and all their thinking, which can look like gobbledygook. but then they need to be able to explain the answer as well. So about the middle of last term, the kids were starting to run out of their maths books, and I'm going, excellent opportunity to put them to the side, get new ones in, and start the process again. And the kids embraced it, and they embraced it very quickly. Some of them, but they were like, oh, I don't have to roll up my page anymore. I've got the whole page to be able to work. So we set this out, we gave it to them. They stuck it on the inside. I'm hoping, yep. They stuck it on the inside of their maths books. They've got it as a guide they can go back to. And we've had a bit of, I've got like bragging rights on these ones. This is we'll pass these round, but the thinner ones are the before. But this is the mathematical sort of stuff that we were getting before. Well, while it's in there, made it very hard as a teacher to identify where they'd gone wrong.
Pictures in the side. You know, we've all seen
Eat,
these.
you know, they eat the books. I don't know.
And they tell you the book's empty in primary school. I
Yeah, it's got to the
Miss
back.
Larry, and then you find 3 pages in the middle that haven't been used.
And this one is this exact same child that I've just shown, and we've got this. Same child, same thinking. We didn't mind if the thinking part was rough, because I know that some people need to do it rough, they need to do it fast. But we're now starting to see their clear thinking and all the steps. And even my faster mathematicians who would go, oh, I know the answer, and they just write it down, but they were maybe 1 or 2 off, and they said, well, how did you get that? Oh, I just did this, this, and this. And I'm like, but where have you got that from? And they're like, oh. So now they're recording that thinking and identifying in the know section where their questions are. What questions? How do I know what I can do with it? What operations am I going to use? So what we would do in class is we sort of put up the problem on our boards or give them a piece of paper with the problem in. And for the first few minutes, they sit there writing all they know. Oh, I could use addition, I could use subtraction, I need to use multiplication, I could record my results on the table. What does this part mean? And then they start going on to their thinking, and then we've got their solutions.
And we talk about, we would talk about everything. Oh, we know there's kids who say, I don't know anything. No, I don't know anything. So then we'd sit with them. What do you know? Do you know? Can you read it to me? And eventually it does come out that they do know something. They know the numbers, they have a question, and just sort of valuing that.
And this would be one of my students who will often sit last term, she'd say, I don't know any maths, I can't do it. And now she's writing more down. She's actually identifying, oh, actually I do know that. I can skip count as opposed to applying my multiplication factor. That's going to get me to that step. So then for her next step in her learning is to identify how she can use that knowledge. And that's what we are sort of working towards as well.
So this is just a short video of just students in Tanya's grade just having a bit of a go.
So I was able to film this because I'm redundant in the classroom at the beginning of problem solving. So I'm wondering if they are all doing this part individually. What you couldn't hear is actually the discussions that the children were having afterwards. And you saw some of the kids flicking their books. They were going back and referring to examples that they'd used before and their notes that they had taken in some of our teaching sessions where I do get to stand at the front of the room and say, all right, the factor is and the multiple is. But that language is now just coming through and they're talking like, oh, well, actually, I could use the multiples of. And just thinking, oh, didn't realise you knew that word. It's really good. They're going back, they're referring. It's actually quite exciting, you know, just to see what's happening there.
And then just, yes, yeah.
Okay, just wanted to ask you, how often during the week of the 5 or 6 or however many lessons they have for maths, do they go to this splitting of the classes?
We do that we do it once a week.
Once a week.
But then
The way that our maths is set up, that there was just an everyday classroom, so we have our regular maths 4 days a week, and on a Friday we give them a different problem where they cross against the 4 classes. I teach with another teacher, and we have an open plan space like this, and between us and then the maths leader, he comes in, so we've got sort of 3 teachers operating in that sort of sense.
For
We'll be
every
trying,
lesson?
most lessons, there are 3 out of the 4 to support us during that time, so we would go through that, yeah.
So we have big classes, so the principal sort of things. If you're willing to have 29, I'm willing to employ a leader. So myself and the other mathematics leader, we're out of the classroom full time. So we get to go into the grades and help with the teaching. And
You've got coaching and mentoring, right?
and just teaching as well with the kids. And
That's
just
why
being-
I've been able to come here, because he's there and I've sort of given me the strength to just come here and show what we've been doing in the classroom.
So every lesson there are 2 teachers in the lesson? In the
Oh
class?
no, well Tanya team teaches anyway, so there's
Yeah.
always 2 teachers in her room.
But we have about 60 kids between the 2 of us, so we have 2 all the time and then a 3rd. So while the kids are quite independent in that there, if we need an enabling group to pull out or kids were really struggling, that's where we bring them either down onto the floor or we've got an area in our learning structure.
But I'm the Prep to 3 mathematics leader. Our classrooms are more portables. We don't have the open plan. So only once a week will we do the problem solving. But then every time we do mathematics, we're using that sort of, we've started to use that system of when we put the problem up, we put the heading, we put the date, we do what do we know about this problem, then we have our working out. And then we also have reflections as well. I just found this, we're talking about travelling the world. If you can't travel the world, just get onto Twitter and then that's the world for you. So I just saw this on, someone posted this during the holidays. After I already knew we were talking about this, and it's about a study from Charles Sturt University, which is about, they looked at ways to improve and students, and they said that valuing the workbook, valuing what goes in the workbook, and that's something that we've tried to do at our school rather than having, we used to have a file book, and so we do a pre-test, then we do the unit, then we'd have something that went in the file book, and then at the end of the unit we'd go, oh shit, they didn't learn anything during the unit because it was too late, the file book. So now we're saying we still do a pre-assessment, which we call a CAT, based on what the students need at the end of the unit, but then we're valuing all the tasks that are during the unit. And then at the end, if we do something like on the blog or something, it's more a reflection of what's been going on, not a sort of a one-off piece that's unrelated.
And like, for example, valuing the workbook, I told my class that I was bringing in some examples from their books. They all wanted them to come. They were all excited.
Proud,
they weren't saying, oh no, don't take mine. They said, oh, you can take mine, that's fine. And like, I'll wander around the classroom, I've got the iPad with the e-server and stuff, and we'll take photos of it. And we've been doing a thing, a showcase on our blogs. And so if I take a photo of it, the kids go, well, can I use that on my showcase? Because I've been able to show my example and explain my strategy to the rest of the class. Yep, sure, good. You know, and it's not always the best ones we choose to give the example. We might start with the lowest entry point and say, well, how you got that? And then other people go, well, if I started there, we can add to this. So the conversation is building all the time. It's really exciting.
But we're not there yet, so we think that we need to make sure we spend more time on reflections and during the lesson and at the end, so that's sort of our goal. I think the grade 5s do a really good job at the setting out of the workbook, but the grade 3s do a really good job on doing their reflections, so we're sort of trying to merge those two skills together. And the problem solving work, that's sort of been the kids have really jumped on that, and you sort of know when something's working when they start using it and using the language. So that's something that we're going to do. This idea of having a checklist for the workbook is something we're trialling in other year levels. In grade 2, we just did a heading and the date. But even that was just so they could go back and find what day they were doing that activity. Even that was sort of an improve on the past. And using like self-evaluation, like are they using the problem solving? Because sometimes we worry that they're going, oh yeah, I'm a good mathematician. They're just sort of rolling it off because they know what to say. Are they actually like living that out? Then we had this idea, Tanya had this idea about student selected and designed problems.
For their Friday sessions.
So, because at the moment we've been sourcing a lot of problems, we use like NZ Math or Enrich, or just old, like I said before, Australian mathematics competition problems. We use those problems as starting point, and the teachers are finding them. But we like the idea of the kids having a go of it. It's sort of, you can sort of see the natural progression. The kids they'll come up to you after a lesson and say, oh, I worked it out for, I found all of the possibilities to 100 for a particular problem. Not just I said, oh, you had to find 4. They go, I found all of them, and they're so excited about that.
Can I ask one more question?
Yeah, sure.
What percentage of your maths teaching do you devote to problem solving and to teaching core maths structured?
We teach all of our units through like a problem solving approach.
All of them?
Yes. Sometimes within that we might have a lesson, we might realise that, say the problem, I know that Tanya's been doing the box strategy, which is a strategy for multiplication. So we might have put up a problem about multiplication and then realised that people were using another strategies, but then we'll have like a workshop type lesson on this strategy. Here's this strategy, this is how we unpack it, this is what it means, this is how it's related to algebra, this is how it's related to arrays, stuff like that. We also run parent nights about these strategies, because things like the box strategy, that's new. I didn't learn that when I was at uni. At uni, I thought the lattice method was cool, and now I realise, well, actually, it's a bit shit, really. The box strategy is a much more effective strategy because that links to algebra and has sort of got a longer lifespan. I can explain what I'm talking about if anyone wants to know later. But it's, I guess it's sort of, we think that all problems should be problems.
And we try and make it so that the real life things, in the sense, like obviously with the Olympics coming up, we're going to design our maths unit around that, because we know that we've got measurement that we need to be covering, and statistics and data, and that's going to be the ideal opportunity for us to find that unit around that. The multiplication and multiplicative thinking that we've been doing at the moment has been based on the challenge and task project that we've been involved in, but it's some of the activities that were in that, which were arrays and stuff, also related to our volume and area unit that we had done previously, so we were pulling all those in so the kids could see it across the board.
That's all, so thank you.